Okay, so the final subtopic will be on Doppler's effect. Okay, let us look into example 10.13. So in example 10.13, you have figure 10.23, okay, which shows O is a stationary observer, and then source S moves toward the observer O at a speed of 20 meter per second and away from the wall T. Okay, and then the frequency of the source is given as 1000 Hertz. Okay, they wanted to determine the wavelength in front and behind the source, okay, if there is no wall T. And then B, apparent frequency heard by the observer O directly from the source. And then C, apparent frequency heard by the observer O caused by the reflection on the wall T. Okay. Okay, solution for A over here. So the observer, okay, will be stationary and then source will be moving toward the observer. So basically over here we will have two wavelength to determine, okay, which will be at the front and then at the back over here. Okay, now the wavelength in front, okay, the moving source, okay, where over here now the source is moving toward the observer, okay. So this one will be minus, okay. So if you look into the general equation, we have plus V plus minus Vs, okay, source moving toward or moving away. Okay, now the source is moving toward the observer, okay, minus, so which will end up with 0.31 meter. Okay, so behind, okay, at the back, which will be the opposite lah, okay, velocity, okay, plus with the velocity of the source, okay, over the frequency, so which will end up with 0.35 meter. Okay, and then for question B, okay, so applying the general equation, okay, we have plus minus VO over V plus minus Vs, so where VO represent observer, okay, where S represents source over here, okay, and then Fs will be the frequency of the source, okay, frequency observed by the observer, okay. Okay, so for this case, okay, the frequency heard will be equivalent to 1065. Okay, if the source is moving toward the observer, okay, you will end up with a higher frequency. And then if the source is moving away from the observer, you will end up with lower frequency. Okay, so this one you can use it to check up your final answer lah. Okay, so over here source is moving toward minus, okay, and then the final answer you will end up with a higher frequency. Okay, or what you can do is that you can use the previous value from the calculation, okay, velocity over wavelength in front, okay, which will also end up with the same answer, 1065. Okay, so for question C, you have a wall, okay. So the first thing is that what we do is that we need to determine the frequency for the wave which is traveling at the behind over here. Okay, so that means the source is moving toward the observer. That means it is moving away from the wall. Okay, so moving away from the wall. Okay, so that means the frequency heard from behind which will become lower, which will be 943 hertz. Okay, so since we have a stationary wall, okay, what will happen is that the sound wave will reflect at the wall over here. Okay, so it will reflect and then bounce back to the observer. So over here the wall will act as a stationary source. Okay, so you will have reflection, so that means it will be equivalent to the frequency heard from the back of the source, which will be 943 hertz. Okay, that's all for Doppler effect lah. Okay, so the important thing is that you should be able to apply the formula with right sign convention. You should be able to identify, okay, when does it becomes plus and minus. This one you have to always refer back to the notes lah. Okay, and then make sure you have a way to identify. Okay, and then another important thing is that If an object is moving toward the observer, I mean, for example, the source is moving, you will get a higher frequency. Okay, if the source is moving away, you will get a lower frequency. Okay, that is one tip for you to check out your final answer. Alright, thank you for listening.